This is a ball balancer. At least, sort of. It all began when this absolute genius of an engineer decided to create this project, inspiring people all around the globe to create projects like his, including me. Now, me being the absolute genius I am, said, easy. It was in fact not easy. There are two steps to balancing a ball. The first step is to move the surface. This is a 3RRS parallel manipulator, or sometimes known as a 3RPS parallel manipulator. It has a revolute joint, a pin joint, and a spherical joint, and these three joints can rotate it along the X-Y axes and also the vertical height. It may seem like a simple concept, but once you dive into the maths behind it, you'll see how complicated it really gets. Fortunately, me being the mega mind I am can explain it to you easily. Imagine you have three identical arms, and we can form a triangle. We need to find where this top point is so we can calculate the angles of our motor. Imagine you have a matrix on the top of your plane. Then, with this matrix, you also have three vectors going from the origin point of your plane to each point. You then also have to define where the center of your plane is. When you multiply this matrix with the vector and then add the origin point, we can find out where these individual points are. Once you've formed and fully defined your item, you can then figure out all the lengths of the triangle that you're trying to solve. We can use the law of cosines and rearrange it for cosine of A to figure out what our angle for the motor is. Now, I'm not explaining all of this in great detail, so you can find this PDF in the description and read if you want to see more interesting things. Unfortunately, my downfall was near. The next step is the camera and the PID. This is an OV5640, or an 18-pin torture device, which needs to be soldered like that. But unfortunately, this guy and his soldering iron do not go well. And yeah, here's why. Then came the next thing. The ESP board. I don't even know what these pins mean. Like, what is that? Ignoring that, the PID is actually a bit more simple. We use the proportional part of the PID to tilt the ball in the correct direction to move it towards the center. So if it's on the right and we want it to move to the middle, we'll tilt it so it falls towards the middle. Then once it's moving, we want to actually stop it somehow. So we use the derivative term to go against the direction of motion, create equilibrium, and make it stop in its place. And then you have the integral term, which is designed for this world to fix small mistakes. Since the proportional term will only tilt it a small amount, and friction will probably stop it from turning, we can keep on adding up the angle until it starts to move a small amount, so we can get it to move exactly to the point we want it to go to. Programming this is fairly simple. You just need to find a good way to be able to track the velocity, speed, and location of the ball so you can properly calculate the values of the PID. A lot of this code is yapping, honestly, and you can find it in the description if you want to continue working on this. Unfortunately, this marks the end of this project, and if someone smarter than me wants to try and continue it and hopefully make something really awesome out of it, go ahead, send me a message on Discord. But until then, I hope you guys enjoyed this video, and I'll see you for my next project.